Question 76 says the figure shows a swimming pool filled with water. A pump is used to remove water from the pool until the pool is empty. When the pump is running, the rate at which the volume of water in the pool decreases is constant. During the first 2 hours, the pump works slower than usual due to a broken piece. Then the pump stops working. The broken piece is replaced and the pump works at its usual rate until the pool is completely empty of water. The entire process of emptying the pool takes 6 hours. Which of the following graphs could depict this situation, where T in hours is the independent variable and the volume of water in the pool in gallons is the dependent variable? Let's take a look at our graph options to determine which one best fits our scenario. The first thing that I notice is that we know that emptying the process takes 6 hours. Upon observing my 4 graph options, graph A goes from a full volume pool to an empty volume pool at 10 hours. So this contradicts the story, so A cannot be a solution. All remaining pictures do seem to appear to have an ending of 6 hours, so that doesn't rule out any of our other options. Let's take a look at another piece of information. We know that we are decreasing at a constant rate, and during the first 2 hours, we are working slower than usual. So I have a change happening at 2 hours. So this right here is from 0 to 2, so that works. C also, we have some 0 to 2 happening here. We're decreasing in volume. But graph D actually has some decreasing going from 0 to 4. So this is going to eliminate graph D because that is going longer than just the first 2 hours. That's the first 4 hours. So really the big difference here is I'm looking between graph B and graph C. The first thing that I notice is that for B, the slope of my volume per time is less steep than in this section, whereas for graph C, the volume decreasing over time is about the same steepness here to here. And that contradicts our story. We had a broken pump, so it was going slower at first. Then we took a break, we replaced the pump, and then it drained at the usual amount. So we should see two different rates of change for this problem. I think our correct answer here is going to be B, as it is the only one that has the decrease for 2 hours, rest for 2 hours, and then decrease for 2 hours. And the two decreasings are happening at different rates of time.